Okay, templates. All right. This was a single code body for a set of related functions and related classes. Wow, that's a terrible definition. Okay. Let's make a function, or I'm sorry, directory called template. Let's go into it. And then first, template.cpp. All right. I'm going to start with a really basic example here. We'll go ahead and include IOStream. Let's say for some reason we wanted to write the function add. Simple example, guys. Int add A, int B. All right. Obviously, we're returning A plus B. All right, let me open that back up. We go down here, int main, int argc, char star, argv. Okay, and then we can do cout add of 1, 5. All right, let's go and see if I compiled that all correctly. I don't know why I put a thing there, but I sure did. G++ first, and then run it. 6. Did I do that right? Good. Okay, makes sense. What if I also want to do it for 1.4 and 5.7? Is that going to work? No. Why does that not work? Right, the type is not correct. Or actually it would, because it's going to try and cast it to an integer. Oh, that's funny. But did that give me the right answer? No. Not at all. Okay. What would you normally have to do here? You'd have to, we'll make them floats. Right. Is ambiguous. Okay. Oh, it's even ambiguous here. That's even worse. All right, so now it's giving us all sorts of errors, which is not good. Let's see what we want. Because it doesn't know that it's a floating add. It's the problem. That's the problem. And now I'm going to tell it it's a floating add in this situation. So this example just became far worse, but that's okay.
Did it recognize 1.4 as a float?
Yeah. Go compiler, right? Actually, it recognized it as a double, is what it did. So if I made this a double, I bet you it would be just fine. There it goes. Yeah, it casted it to a double. And then what happens if all of a sudden we were doing strings? Oh, this is getting complicated. We'll go ahead and include string real quick. All right. I didn't even add it. Okay. Of course, if I didn't have this function, it wouldn't work because it's not defined. All right, so what's the pattern with all three of these functions? The same exact code. All right, so it would be nice if we could just write this once for any type that we want to. That's what templates do. So instead of having to do all this nastiness, we go comment that out. We go template class T. By convention, we like to use the word T. We'll have a return T. We'll call it add. The first one is an A, and the second one's a B. T is defining the type. So we say this function is going to be templated on T, so there's going to be some type T whenever you try and call the function add. Is that off the screen?
Yeah.
Wow. That's kind of.
I'm not seeing the output of the program.
Someone needs to fix that thing. Can we like beat it or something? That's pretty terrible. Huh. All right, don't tell CSU I did this. Is that open?
It just needs to zoom in.
And you know what? I don't even have the remote.
I thought they had them in the safes, man.
Guess what they did not give me?
Really? That upsets me.
Oh, look at that. It's open.
Oh! Feels. I didn't want to say anything, but I opened it everything.
It is zoomed out as much as it goes.
Is there a move left or move right?
I'm sure there is.
I didn't think it's still there. See, everything's still there. I was just being a hero.
He's in the way.
Anyone know where this is before I have to sit here and look at it for like 30 minutes trying to figure out what's reset?
The settings.
I'm not
I would
touching
guess
that.
settings as well.
I'm not doing that. That's,
Oh,
oh,
something changed. Oh.
that
Almost
doesn't
there.
help.
You didn't close. No.
Nah, it didn't help.
I'm wondering, I mean, you like zoom in, like.
Yeah, I hit zoom as much as I can and then,
Oh.
Wow.
You gotta zoom out.
Zoom out.
yeah, that's it. It doesn't, it no working.
That's
A little bit left and right.
There's usually like an adjustment, and that's usually in the menu. Image, presentation, brightness,
settings. So
sharpness.
you gotta go to settings. Check the settings.
I am in, oh, settings, keystone, split, square, volume.
You know what I mean?
Oh.
What's that? Oh,
One of these dials can't do it.
It's gotta be in here
There's two
somewhere.
dials, one's a focus and one's a zoom.
all right. So we're going to do this completely differently.
If you go to stand in your chair, you can just move it to the right.
I tried to, it was pretty screwed down. Okay, so I'm going to close this file.
There's two dials on it. The actual projector itself.
GVim, first template. There we go. Okay,
And.
there we go.
Hey.
Hey! All right, template, class T. I'm saying that the following compiler, you figure out what T is. It's going to return a T. It's going to add the first parameter is T. We're going to call it A. The second parameter is of type T. We call it B. And then just do it. So, C++, if I wrote this correctly, is going to create 3 separate add functions for me. What happens is it says, okay, that's a template. That's great. Once I pass it 2 integers, it automatically creates that function with T being int. Once it sees a double, it creates that function with T being double. And then when I do it with strings, it automatically creates that function with T being string. And then compiles it. All right, let's see if I did that right. Nope. Invalid for constant char, constant char. That does actually make sense, because those are constant chars. So, oh, I have failed us again. Just to show that it does actually work. It couldn't cast a constant char to a string, but it could when I wrote the function manually, which makes very little sense. Thanks C++ for making this more confusing. And then that should work. Yep. So I tell it, hey look, it's an std string. We're good to go. We really should have come up with a different acronym. Yes.
Yeah.
Yeah,
I
I
want
was
one of
about to
those.
ask that in procedural programming we used using namespace std. So is there a particular reason you aren't using it?
Yes, I don't like putting using std in my programs. It just, it doesn't. I gotta let that one go. I'm just not gonna do that.
I thought we were gonna get to something like, oh, it does something with, I don't know, the bytecode or something like that.
No, I just don't like typing using std in my program. It's not. It just, I can't do it. I can't do it. So I just do it this way.
I'm done.
You're done.
I
All
feel want to save you that much work.
Yeah. Yeah. All right. Any other questions? Good. All right. So this is the essence of what templates are for functions. And let's see. So yeah, they did a function declaration. Notice that before the function, you have to put template class T. You don't have to use the symbol T. It could be K. It could be V. It could be super duper. As long as, of course, you use that inside of your function. By convention, we usually use T unless there's a very good reason not to, because T stands for type.
I got it.
You got it?
I got it.
Okay. All right, class template. Wow, they say a lot of words, and I've already showed you how this works. Okay. Now let's do this with the class. So that was our first one. Oops. Second template.cpp, and then we'll gvim second template. All right, someone give me a class, something else that can be templated on, that can have multiple types. What's that? I couldn't hear you.
Or, well, that's not class.
You can have multiple buildings.
Multiple types of build? Remember, it's multiple types. Oh, okay, sure. Why not? We'll make another zoo. Why not? Oh my goodness. I really should just copy the other zoo code over. All right, let's do that. Yeah, then we'll just put it all together. Okay. Okay. So if we're going to do that for our zoo, we go template class T. Oh boy. All right. And then I guess that would be our type of animals, right? So if our zoo for some reason was having an integer type or a double type, I'm just rolling with it, or a string type. Here we go. And all these other operators are probably not going to make much sense anymore. Well, that one does. That one does. Okay, hold on. Let's start from the top because this is going to get weird. Lion and tiger, so we have to be able to convert that to a type. Yeah, that's not going to work anymore. I'll get rid of that. Plus plus. Yeah, that doesn't work anymore. That never worked. This time it will return a type T, right? Because we're going to get it at a certain position. We can still add, but we need to clarify that it's of type T. All right. Oh my goodness. So we can set them equal to each other. That sounds great. That should still work out. Yep. And we can still print things out. Sure, why not? All right. I wonder if this is going to work at all. We'll find out. If this works the first time, that'd be amazing. Didn't think so. Missing template argument before zoo. Oh yeah, because I am, for some reason, had a weird moment where I just put it in the wrong location. Yeah, silly me. Okay, there we go. Oh, whoops, over here. Alright, no match for operator plus, probably because we got rid of it. No matching for equals of, oh my goodness. Yep, that makes sense. We can't set zoo3 equal to regular zoo because zoo3 is of type string. Hey look, it told us that, so we'll make it an integer so they can actually be the same type. Hey, and it worked! Okay. But now we need like an add function or something. So that's because our zoos are empty. So let's create a quick add. We'll make it a T, call it an animal. Animal. We'll call it m animals sub m num animals plus equals animal. Perfect. So now in our first zoo, we're going to get rid of that. Zoo.add, we'll add the animal 15, the best animal ever, and 78, as well as. Alright, you know, let's change this one to a string. That's going to make way more sense. And then we'll print that guy just to make sure it works. Hey, look, okay, good. So, zoo2.add, what's our first animal?
A pig.
Which one?
Pig.
Pig? Good old pigs. Next?
Pikachu.
Pig.
Rhino. Pig 2.
How do you do pig? Is it P? Is that how you spell Pikachu? I don't remember.
Yes.
Alright. Yeah, it's because Pikachu. Yeah, that makes sense. Alright, next.
Big pig.
Big pig. Alright, let's see if that worked out. Well, we probably should print afterwards.
Yeah.
There it is. And we could create an animal class, template the zoo on the animal class, and then be able to add animals that are of different, that are type class or animals. Sorry. Okay. Starting to see why this is useful because now I can specify what the zoo type is. Yes. Notice that when you create the class, you have to specify what its type is. When you are, when you're instantiating an object, you have to specify the class, the type. Wow, let me start that over. When you instantiate an object where the class is templated, you must specify what the type is that's being templated on. There we go.
Now, when you have what is the operators called? The greater than, less than?
That's great. Sounds good.
Okay. So those just deal specifically with templates.
In this situation, yes.
Okay. Okay, because I wasn't sure because when you were casting, usually you do the parentheses.
Yeah, that's casting. This is declaring the templated type. How are we doing so far? Good. Okay. All right. This is hard to, I can't really show this. You just have to know it. Templates are created at compile time. When they are not created at runtime. This is the difference with Java. When Java uses generics, which are basically the same thing as templates, the difference is that Java instantiates or creates your new class during the runtime of your program. C++ creates the new class or functions during compile time. In other words, whoops, I don't know why I did that. When I do g++ zoo.cbp, the objects have been, or the classes have been created. All right, they're done, they're gone. They're now compiled code. In Java, when you run a.out, that's when the classes are created. That's the difference. Hopefully that will not make a difference for this class, but if you ever get deep into Java and C++, you'll understand the difference pretty thoroughly. Oh yeah, the header files. Okay. We have not been doing header files. Again, what's that? Kind of? All right. It is best practice to not put your code inside the class inside of C++. That is very different than Java. Java, you put your code inside the class. In C++, it is not good practice. Instead, you want to make a header file. So for example, let's do the constructor in a separate header file. How are we going to do this? And your header file would be the class definition, which would be all that. So we'll save that, tab new zoo.hpp. Go ahead and paste that in. Great. And then you have pound if not defined zoo_hpp. Define it. Go to the end. And if. All right. So right now we could just, let's get rid of that. zoo.hpp, and we're done. All right, and that should still compile as it stands. Right, good. Because it's just pasting that code from the header file right here. Okay? Now, in reality, you should be doing something more like this, where you put zoo, semicolon, and then you want to copy, oh boy, that code back into a CPP file. So zoo, colon, colon, zoo. And then that's where you'd set num animals. Oh, you can't see this. You gotta tell me, guys. Equals 0. All right.
So,
Taking this a step further. Main.cpp. We'll paste main right in there, and we'll include zoo.hpp. All right. So when I go back to compile, I'm actually compiling zoo.cpp and main.cpp, and then it didn't like that at all. Has class zoo declared here invalid use of template type zoo without templated argument list. That's right, because I did not actually do that correctly. There we go. And also, this is a function. Let me try it one more time. Oh, good old C++ standard out has not been declared. This is inside of zoo.hpp. Probably should include it. There we go. All right, now we just have undefined references because it hasn't been declared. Yes, it has. Ah, right. This is the error. This is what's hard to explain. Because if we put the code right over here and not in here, it's going to work. I didn't like something. Thanks. All right. Okay. Remember with your classes, hopefully I did this before, if you have your main just includes the header file and then starts using it. HPP is just supposed to declare the function. It's not actually supposed to implement them. And then your CPP actually has the implementation. But the error is that in the header file, if I try and take this code out, let me show you the two examples I'm trying to do here. And I just do zoo, semicolon, that declares the function. And then I try and implement it here, I'm going to get a unresolved reference to zoo. All right, here's a tough question. What is going on? Because this is probably super confusing.
Did we not include the header file in the zoo.cpp?
You're right. No, it's right there, zoo.hpp. Inside of zoo.cpp. Main has it, and then, of course, zoo.hpp just is declaring it. Okay. Ooh. This is tough. Let's look at main.hpp. Zoo sub int of zoo. What's that going to do? Right. What's that? It will try to. It wants to create a zoo of type int. Can it? It cannot right now. Does anyone see why it cannot? You're including the header file, but the header file doesn't have the implementation of the constructor. So when main.cpp is compiled, it is not able to generate the constructor function because it doesn't have access to that code.
So basically, we won't see it until
you compile the zoo.cpp, but by that time it's too late. It doesn't know what types it's supposed to be generating. Now, we could kind of get around that by doing this. Zoo, I think it was zoo sub int semicolon. This is a weird syntax. It didn't like it. Does it tell me in the slides the right way to do that? Nope. Thanks, slides, for betraying me. There's a way to force it to create the zoo of int by doing it that way. I am not going to teach you to do it that way. Instead, at the end of a header file, you include the CPP. Previously declared here. And when you do that, you don't include the CPP in the file compilation. Right. Okay. Hold on. This is bad programming practice, but a side effect of templates. Bad programming practice because you're not ever supposed to include actual implementation code with your header code, but unfortunately I have yet to see anyone fix this problem efficiently in C++. If someone ever finds it, because they come out with new standards all the time, maybe they finally have fixed this somehow, but I haven't seen it yet. So let me go through and do this for each function because that's how you're supposed to do this. So the heading for this operator int pose would just be a semicolon. We'll go ahead and create that. Go over to CPP, template, class T, and then here it's returning of type T. We'll have zoo sub T : operator because that's how you get to the function. Ooh. This is going to be a long one. All right. So I did it for those two. Let's stop there and just see if it compiles. Good. You see I could do that for each one of them? I think you can see what's going on. All right. Yeah, so when you're doing templates, which you will be in your lab, I stubbed out the header to get you started. You're including a CPP. It's bad programming practice, but unfortunately that's just the way templates are. Okay, so do you understand the power of templates right now? By being able to basically delay what the type is? Not at all? Okay. Anyone?
I guess that'd be useful. Maybe in certain situations.
Maybe it'll make more sense in the lab. Beautiful.
I think there's something to work with it and actually like hands-on with it.
Okay, any questions about templates, what it does? Let's start there. I think your lab will give you a solid example about why they're useful. Yes?
So when you include T, that's just when you try to run, say like the string your name, T would know that you're trying to run that type of.
The compiler is going to infer what the type is.
Okay.
So the compiler is going to try and guess what the type should be. Excuse me. Well, I shouldn't say guess. It's going to figure it out. And if it can't, it'll tell you.
Okay.
All right, we'll go to the lab.